Hello everybody and welcome to this 7th tutorial on TextFabric. In this one we are going to focus on the use of relational operators. Relational operators are an essential part of query writing because they allow us to define the relation between two different linguistic objects. So let's first get the Workbench started. So we have loaded already here our pandas tools and then TextFabric and then our Old Testament text, BHS, as well as the New Testament text, the Tischendorf text. In fact, I have created a new feature for the BHS text lexicons. It shows the lexemes of each word, but they are only the consonants, none of the part of speech markers like the slash for nouns or the square bracket for verbs. This allows me to find some interesting rhetorical words with plays with word. Okay, so what are relational operators? Basically, relational operators, they define the relation between two linguistic objects. So let's say you have element A as one linguistic object and element B as another linguistic object, and you want to say that element B needs to follow element A. Well, how do you do this? You do this by the use of a relational operator, and this would be our relational operator. So basically, once we use it, it tells us element A needs to precede element B, yeah? Or to say it the other way around, element B needs to follow element A. So while the operator, this reverse arrowhead, this operator makes element A precede element B, it does not define the distance between these two elements. So if you use this, you could find any of these scenarios. You could say you can find those cases where element B follows right after element A, or where element B follows after element A, but there are some other elements or one other element in between, or there are two elements in between. Any number of elements can be in between element A and element B, as long as element B follows element A. Yeah. So if we want to have element B follow right after element A, well, then we need to use a different operator, and this is the sign, the reverse arrowhead with the colon. So what this tells you is that element B needs to follow right after, that's kind of this colon sign, right after element A. So let's have a concrete example. Let's pull up here first John 1:1. This is the verse, John 1 verse 1. Let's see, we want to find all cases where we want to find all words that follow right after logos. We want to find all words like kai or hen that follow right after logos. There are three logos in verse 1, logos, logos, logos. For the last logos, we shouldn't get any results because there is no word within that verse that follows logos. So in order to also see nicely our results, I make sure that the word that follows logos is colored in magenta. So here you see the query. John chapter 1 verse 1. And in that verse we want to find the word logos. Here it is. And it needs to be followed right after logos. We want another word to follow. And this is the sign. Right after the previous word, which is logos, right after, see the colon, we want a word to follow. We don't define the word, but the fifth line of our query should be highlighted in magenta. 1, 2, 3, 4, fifth. So this will be highlighted in magenta. Let's run this. Here we are. We have how many? 2 results, right? And that's what we should have, because we should find kai and we should find hen. Here it is. Kai, hen. So what would happen if we would use, instead of this operator, this? You see, it only tells us we want to find a word that follows logos. So in that case, we should find many words, because there are many words that follow logos. And let's run the query. Here we go. Let's look at the results. You see kai follows logos, right? But ho follows logos also, so we should have ho also. Yeah, ho. And logos follows logos too, so logos should be highlighted too. Yes, and hen follows logos too. Yes, right. And then of course we can go until the end of the verse, because this one is the last word that follows logos in this verse. So we should have that final logos highlighted too, right? So this is the last word that follows logos. But then the query says we want to find each logos followed by a word. So the next logos is this one. We should now find hen again. So you see now it starts with the second logos and it identifies hen, and will identify pros and ton and so on. Yes. And then it goes to the last logos, but that last logos doesn't have any word that follows, so it shouldn't find this. So in total, we have 21 words that are identified by this query. So of course, we could now reverse the order and say, we don't want to find the word following logos. Well, we don't want to find the word or words following logos. We want to find the word that precedes logos. That precedes, that is, logos needs to be adjacent to the word before. Yeah. So we want to find ho, and there is our third logos, ho. So 3 times the article ho. So how do we do this? Now we just reverse our operator. We say we want a word to precede right before logos. We just reversed this arrowhead. And we should have 3 results. Let's see. Yeah, 3 results. You see, ho for the first logos, ho for the second logos, and ho for the third logos. Okay. Now, an important part of query writing is to have a clear visual realization of what you're actually querying. For that purpose, I want to introduce you in a way that helps you to organize your relations between linguistic objects in a little better way. So in order to explain you what we are suggesting here, I want to clarify or make you aware that the order in which you put the linguistic elements don't play any role. It's only the indentation. So see here we have 3 linguistic elements: verse, word, word. Now the first word that I'm mentioning here is logos, the second is theos. In Shibang, if you would write an MQL query, it would mean that first comes logos and then right after logos theos needs to appear. But TextFabric doesn't follow the MQL query syntax. So for TextFabric, it doesn't matter whether you write logos and then theos or whether you write first theos and logos, it will find the same results because the order of the different lines don't play a role. It's just the indentation. The indentation tells you that these 2 words need to be contained in verse. That's the only information. The order doesn't play any role. So if you want to define the order, if you want to, for example, that theos follows logos, you must use an operator, a relational operator. So in this case now, we have theos follow logos. So after the word logos, at some point, theos needs to appear within the verse. I could write it also differently. You see, I first have now theos mentioned and then logos mentioned, and I just reverse the operator. So it basically now says before theos, this is what it does, before theos we need logos. You can imagine that when you have many linguistic elements, it will become kind of messy with all these operators in the beginning. So what I like to do and suggest to you is that you are defining your relations between the linguistic elements at the end of your query. And you do this by giving placeholder names. So we have a verse and then we have 2 words, logos and theos. The first word I give the name W1 and the second word I give the name W2. Once I've written the query, I then add the relations sector. Here I define the relations. I say W1 needs to follow W2. This does exactly the same as if I would write it this way. It's just nice and clean because the relational operators are kept outside of the listing of linguistic elements. At least that's what works for me quite well. So to prove my case, let's search in both ways. Yeah, so let's first search this way. So we say here theos needs to follow right after logos. How many times do we find that in the New Testament? 2 times in First Thessalonians and Timothy. And now we say exactly the same, but we now put the relations between define the relations between the linguistic elements at the end of the query. You see, I just used placeholders. I didn't put any relational operator in here, but now I follow and say W1 needs to proceed right before W2, and I should get exactly the same results. And here you go. We find also only 2 cases, the same cases. In fact, for the engine, for the query engine, this is a little faster. See, it uses 0.31 seconds in order to find the results, and it uses 0.32 seconds to find the results in this way. Don't ask me why, but this is a little faster. Now, there are many more relational operators, and we just got introduced into 4 of them, and you will most likely use them most of the time, but there are some other very popular, often used operators. You can get a list of all operators by putting this command into your code cell and run it. So there are about 20 relational operators available to you, and I'm going to list some of the most important. You see that there's a whole list of operators that use the K, which stands for K nearly option. What does that mean? Is it basically helps you to define the distance of words between 2 linguistic elements. So, for example, if you want to say, I want to find the first 6 words of John chapter 1, the first 6 words of John chapter 1, you can do this way. You say, I want to find, in John verse 1, I want to find all words that have, that appear in a range of 5 words. So what it does, it will identify 5 words that appear between the very beginning, this is this colon sign, very beginning of the verse, until its final word. So let's do this here. You see now we have defined a distance of 5 words. 1, 2, 3, 4, 5. This is my distance, 5 words, and then the 6th word is identified. So basically what the set says is, I want to find the word that comes after 5 other words. That's what it says. So we find the word that comes after 5 other words. Let's change this into 6. That means we want to find the word that comes after 6 words. That's the word that comes after 6 words. 1, 2, 3, 4, 5, 6. Yeah. Okay. So the other option is you can search a range, define a range. Let's say a range of 3 words. What this means is, in this case, we're searching in John verse 1:1 the word Kai, and we want to identify all words that appear in a range of 3 words around Kai. So what you see now in the results is we'll find Ho, because that's in the range of 3 words to Kai. 1, 2, 3. And we will find Logos. And we will find Kai too, because Kai is also in the range of Kai. And we will find Ho and Logos and so on. I have a screenshot here where you can see what that does. So the proximity of 3 words generates these results. So basically it says we allow for a distance of 3 words until we find the final word. So 1, 2, 3, final word, or 1, 2, 3, final word. You can again write the query also in a different way by saying we just put the relational operators at the end. I like to do that, which is very handy. So you can obviously add several relational operators. For example, in this case, we are saying in John chapter 1 verse 1, we want to find Kai and another word. So we want the first word, we want to have the second word appear in a range of 3 words from the first word. But at the same time, we want the second word, W2, follow W1. So basically what we want is, we only want to find these words, but we don't want to find these words. So what we have to do is we need to exclude that we're looking before the words that are before the word Kai. And that's what we do here. We say we want to find a range of 3 words, yes, but we know when we search for a range of 3 words, we will find this. No, we want to find a range of 3 words, but want word 2 follow word 1. And that will result in these results. And we have now excluded everything that goes before. Okay, good. So let's have a look at a couple of other very good operators that you will probably use frequently. The double equalizer sign that allows you to define that there's just one element within the container. So, for example, here in Genesis chapter 1, we will want to find all object phrases, and the object phrase needs to have a word, but only one word. That means from the beginning of the object phrase until the end of the object phrase, we only have one word. So if you run this query, you'll see that one word within this object phrase. Only one word within this object phrase. If you would not use this operator, it will also find cases where you have many words in an object phrase. That's what the second will do. So let's do this. And now you can see we will have object phrase with 2 words. But then object phrase with just 1, and then object phrase with 2 words, and then object phrase with just 1. So once I use this, I only allow one word, the same word, or one word that starts with the phrase and that ends with the phrase. Okay. There are some other powerful relational operators that I like to use, and they have to do with matching. So here you can see a list. So imagine you want to find 2 adjacent clauses. Yeah, we know how this goes. But you want to have the same lexemes appear in these 2 words. So here an example. In the book of Genesis, you want to find a clause 1 and a clause 2. And clause 2 needs to follow clause 1. You see this here. C2 follows right after C1. And you want to find a subject phrase in clause 1 that should have a word in it. And you want to find in the second clause an object phrase, and you also want to have a word in that object phrase. And now comes the trick. But you want the word that appears in the subject to be identical to the word that appears in the object of the second clause. So let's run this query. And here you go. So the first clause says, let there be light, and it was light, and it was light, subject, the light was, subject, light, or in subject position, and now or should appear in object position the next clause. And it saw Elohim the light, you see, object clause, or appears in the object clause. So the fact that we find that 2 identical lexemes in different subject, in different phrase functions, you see here Eretz, and it brings forth the earth brings forth Eretz, but in the next clause, Eretz is in the object position. Yeah. Good. So this is done by defining w1 word1 dot lex dot w2. It basically means they share the same lexeme. Now imagine you want to find words that don't share the same lexeme, but they do share the same consonants. For example, here in Jeremiah 11, 1 till 12, you find a wordplay that says, and I set a twig off, oh, well, it says, and the word of the Lord happened to me, saying, what you see, Jeremiah, and I said, a twig off an almond tree I see. Shaket is almond tree. And it said Adonai to me, good you're doing in seeing. Yeah, I watch, watching I am over the word to do it, over my word to do it. So you see the word shaket means almond tree, and the word shoket means to watch over. Two completely different words. They're not having the same lexemes, but they have the same consonants. So if you want to find this, you can say, find me in Jeremiah 1 now, two words, W1, W2. The second word needs to follow the first word. And you know, we can also say, I want the second word actually to follow within a range of 20 words. And then you can say, I want the consonants of the lexeme to be identical. Consonants of the lexeme need to be identical, but the lexeme itself needs to disagree. Different lexemes, but same consonants. So let's run this query. And here you see 4 results for Jeremiah 1. Melech, king, Malko, Malko, that's kingdom. Melech, Malko, Melech, Lako. And we have here Shaket, Shoket. 2 different lexemes, but the lexemes have the same consonants. Another example where you use these features is, for example, if you want to find all cases where the number of the predicate in a clause is different to the number of the subject, of the word that appears in subject. So in this case, we want to find 2 phrases. The second phrase, P2, is a subject phrase. And we want, that's kind of redundant, I don't need this, but anyways, it just says P2, it should not be P1, but I have defined P1 as predicate and P2 as subject, so I would not need that line. Anyways, I'll just keep it here. Then I say that word 2 needs to be the only word that appears in phrase 2. Yeah, and then I say that the number of word 1 and the number of word 2 are not allowed to match. Run this. Here we go. You see bara Elohim. Bara is singular, Elohim is plural. Vayomer Elohim, Vayomer is singular, Elohim is plural, and so on. Of course, you can now do this with all kinds of things. For example, persons. Let me use this as a final example in this section. Part of Hebrew syntax is that the pronominal suffix is used when a personal pronoun is used together with a pronominal suffix in the same phrase, that they usually match. So, for example, here you have a phrase. I want 2 words within that phrase. The first word needs to be a personal pronoun. Part of speech is personal pronoun. And the second word can be any word. However, you see I want that the first word and the second word are not identical, so they need to be 2 different words. And I want the person value of the first word, first, second, third person, to be identical to the pronominal suffix person value of the second word. So when you run this query, you have 319 cases where it's always identical. Huh? You and your son. You and your wife. You and your son. You and we. You with you, or you, I don't know. You and your house. and so on. You see, they always match. Because this is what we defined here. It's a normal phenomenon for Hebrew syntax that there's always a match in person normally within the same phrase when you have a personal pronoun and a pronominal suffix. So let's look for those cases where we find deviation. So where the pronominal suffix is not identical to the personal pronoun. So here we have again our first word, personal pronoun. The second word needs to have a pronominal suffix. It can be first, second, or third person. That's the only thing we require. So, and then we say that the person value of the first word should not match with the pronoun suffix person value of the second word. Let's run this query. And interesting, when you go through these results, you get to there are just a few, and not several hundreds anymore, just 32 cases. And when you look at them, you see that there is a rhetorical mean being executed through this use. When you, for example, look at Exodus chapter 33, that's one of the cases where it appears. You have a discussion between Moses and God about whose people they are that are rebellious, right? Exodus 33:16, you see, I and your people. It's an argument between God and Moses. Moses tries to say, no, it's not I and my people, it's I and your people. And by this he deviates from the normal syntax pattern to clarify God is the owner of the people, and so he should take responsibility, I and your people, over it. Okay, I'll skip the gender incongruency. You see the logic of it. But I want to show you now a couple of cases that are interesting from a syntactical perspective and rhetorical perspective. You can find, for example, cases where the same consonants appear in two different words. You see here in Treni and in the Book of Lamentations, I want to find two clauses that follow right after each other. And I want the word one and the word two appearing in two different clauses. I want them to share the same consonants. So that will usually identify anaphors, for example. You see here, hayeta, hayeta, kol, kol, lo, lo. They are all appearing in different clauses. Yom, yom. Let's do condensed false, then you can see it better. Here we have the clauses. Rabati, rabati, hayeta, hayeta, kol, kol, lo, lo, yom, yom. You see these parallels and sometimes anaphors. Ma, ma, al, al. Yeah. Okay. You can also define syntactical parallelisms. For example, in the Book of Psalms, and searching for two clauses, clause 1 and clause A. So, and I want, let's call this clause 2. Okay, clause 2. And, you know, I want 4 phrases in each clause. Phrase 1, phrase 2, phrase 3, phrase 4, and here I call it phrase A, B, C, D. And I say I want them to have the same phrase functions. I want them to be completely parallel with regard to phrase functions. And I add to it that the first word appearing in the first, the word appearing in the first phrase and the word appearing in the first phrase of the second clause need to have the same consonants. And so now you find syntactical parallelisms. Let's have here condensed false so that we can see this better. Now you see waf, waf, and then we have a complement phrase, and then we have lo, lo, and then amat, yashaf, the verb. At, in both cases, at, then we have the verbal phrase, then we have the object phrase, and then we have the complement phrase. Yeah, so we find now always these parallelisms. Okay, so that was it for now. In the next tutorial, we're going to have a look at how to define exclusions and inclusions in your queries. If you have any questions, let me know. See you until next time.